Hey, hey. Yes, like that. All right. Yes. Keep it like this. Okay. There's that one. All right. Connection of how we this one. Right. How about my hair? Hmm? Oh, where is that? Ah, here. Should have something on a charging system. Doesn't work very well. Okay. Yes. Let's. 1709. Use this to alter that. Okay, and we're gonna stop this. ภาพยึดมาแล้วนะนภัสมาแล้วด้วยmoment ไปไหมฮะไม่ไปthis one streaming software no it's not made for kids blah 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 okay just this one and all right I hope it works well right so let us check here yes please yes and oh here you didn't let it run okay seems to be fine right I hope so also stop this alright and let's take a look at this then close the microphone here and open this one wait why okay and this one yes okay 1 2 3 yes the sound just come in we start first good morning I need to check whether the words working fine or not test 1 2 3 yes all right yes I hope this one works. Okay. Good morning, everybody. Sorry for being late. We will go ahead with the chapter 5, right? M60426 here. 60426 here. All right. Okay. Same file, and yes, we arrive at the problem, right? A problem that is related to มีใครจะเข้าที่เขาเรียกว่าอะไรที่ซูมไหมครับก็จะพยายามชำเลืองมองให้นะครับ we almost complete the whole thing here, right? Yes, but it's very complicated. Okay, because this is the last topic of our chapter, and I heard that we are going to have soon the midterm exam, right? And the exam is gonna be held at the school, okay, physical way. And yes, I hope that you would be ready to. I would say that the homework on site. No. The midterm exam on site is gonna be harder or more difficult than the one you usually see in the one you usually see in the last semester, okay, and that's more difficult, I would say. No, the one in the last in the previous semester is easier, okay. It's only 7 problems, and you just write, okay. You just write down the solution, right? So and that's it. But in the midterm exam, which will be held at school, you would have 30 or 40 problems and a few more problems to write down. So it's written exam or something like that. So yeah, you would realize that it's a little bit more difficult, right? Yeah. Yes, let's talk about the exam. Usually, one important thing is that you will be the only program of your school to have the midterm exam with calculator. Okay, you are allowed to bring an electronic calculator with you. Okay, I will talk with the teacher at your school. Okay, so that you have no problem when you bring a calculator. Okay, which will be very, very different from other students. Okay, even in the same year as you. Okay, in Mathematics 6. Okay, you will be only M604 and M605 will be only 2 classes. Okay, that are allowed to have electronic calculator with you at hand. Okay, to solve the midterm exam. Okay, you are also able to not bring the calculator inside the midterm exam if you believe that you can use your brain to take some decimal results without any calculator. Okay, but I don't know what about the arc-sine or something like that, or arctan or exponential or something like that. I don't know how you would be able to get the results. Okay, yeah, anyway, I would give you first the introduction about midterm exam that will be held at school on site. Okay, let's get into this story. yes, the sheriff, like it's like a police. He has shot. He tried to shoot this person, but the piston has missed this the body of this person, the bad guy, okay, who steals something from the people. So yeah, that's so he's not a good person. So yeah, we try to the policeman try to remove him, okay, from the society. Yeah, and the bullet actually has hit the container, the water tank of the town, and yes, you would be able to imagine that the piston is gonna be broken and there will be hole, right? And what you can see here is the hole, okay? And of course, because there is water inside the tank, okay, staying inside the tank, and it's gonna flow out, and we are gonna find what is the distance along the x-axis in the horizontal way. okay มีใครอยู่ที่ซูมใช้สิทธิ์ครับคือผมยาวแล้วผมขี้เกียจใส่หูฟังเลยมันรำคาญแล้วไม่ได้มัดผมนะเวลาไม่พอโอเคyes ถ้าคนที่ซูมจะพูดอะไรก็เรียนเชิญนะครับผมพยายามใส่หูฟังคุณนะ alright okay yes the problem is that we will apply alright we're gonna apply the Bernoulli's equation, okay, the summation of three terms of pressure at any state, right, which will be equal to each other. Alright, yes. มีใครอยากเข้าอยู่ครับใช้สิทธิ์พิมพ์มาแล้วนะ okay yeah the one here I didn't send you the link of the YouTube, right? There are three channel, right? This one too, right? Oh, I have to close this one actually because it's gonna consume the internet bandwidth. YouTube and no, it's your channel. Okay, let me. Oh, no. I don't understand what this one. Alright, in yeah, what is that? The line chat program tab right and tab right, and yes, we're gonna have these right.ไม่คุ้นมือเลยครับคีย์บอร์ดทำไมครับอะไรกันwhere's the line? Okay, line is here in M604, right? 604 copy and control V, right? The first link. Oh yes, we have to stop and this is another link, right? Up to you. Okay, I have to stop too, right? And this one here มีปวินครับมีปวินอยู่คนเดียว okay yes sir okay yes the right the Bernoulli equation is what we're gonna use to solve these, right? And Yes, we would go ahead with that. We want to determine the distance x, right? It means we would need to know somehow the velocity here vx, right? Okay. Yes, let's go ahead with that. At the first location, the pressure which is caused by the air here is PATM, right? And of course at the second hole, okay, second location, it's also the same pressure, right? The pressure caused by the air. Let's say wherever, okay, if you leave if this scenario happens on top of the, I don't know, the high mountain in Nepal, it's going to be the same, okay, because the pressure difference between these locations is minimal, okay, it's very, very tiny, so we don't need to pay attention so much attention to that, okay, because it's only 0.5 meter different, right? They say the water level is 0.5 meter above the hole. So yes, here you have the level 0.5 meter. Okay, this problem is a little bit complicated. Actually, the story here is complicated because there are 3 terms you have to worry about. All right, PATM, right? The first term, PATM. Okay, and the second one, of course, if you compare it, here you have Y1, you don't have any height, right? It's measured with respect to the water level. There is no potential energy at all, right? I don't know how we call it. How do we call it? I don't know how we call it in, right? Yeah, potential energy per unit volume, okay? There is no potential energy per unit volume at the no potential energy per unit volume. Okay, there is no potential energy per unit volume in this at the first location, which is this one here, this location. Okay, and V1, this is the first location, right? Vx, we don't know Vx, right? In I don't know how to do this solve. All right, there is no speed, okay, of the water at this location. Okay, so V1 is 0. All right, V1 is 0, and V2. Okay, let's talk about the second location here, the hole here, right? First, we have to look for the pressure, right? P2, the pressure of the air at this location. Okay, let's just take a look at this. The pressure of the air at this location will be the same. Okay, it's not, the height is not so significant. Okay, it's not meaningful, 0.5 meter only. So P2 is gonna be the same value, PATM, right? And Y2, of course sorry for it คอยังไม่ค่อยดีนะครับP2 is the height, okay, is the height of the second location, okay, it's the depth actually measured from the water level here โอ้แอร์เพิ่งทำงานครับเพิ่งเย็น okay yes y2 is what is that yeah as you know it's here it's what is that it's 0.5 meter right it's 0.5 meter so we're gonna write down here 0.5 meter and the velocity here is vx which is what we don't know okay v2 is vx and we need to find right okay you substitute these parameters, these values into the Bernoulli's equation. Bernoulli's equation says that the summation of three terms of pressure remain the same for any location, right? P1 plus 1 by 2, right? This 103, okay? Equation 103 rho g y, okay, the potentiality rho g y1 plus 1 by 2 and rho v1 square equals p2, okay, the pressure at the second location, and plus rho g y 2 and plus 1 by 2 rho v2 square, okay. You know that we live this environment on Earth, right? The gravitational acceleration G will be the same for both scenarios, right? And we use the same kind of liquid, which is water. So the density rho, right? The variable rho is gonna be the same, which is 1,000 kilogram per cubic meter, right? Yeah, it's not difficult, right? So yeah. Next one is that we are going to substitute everything in here. You know that this P1 is PATM, right? Rho is rho g y2, right? But rho g times 0 is going to remain 0, right? And 1 by 2 and rest. No. Y1 is the height, okay? It's the Y1 is 0.5 meter. No, it's not 0. Y1 is 0.5 meter and Y2, okay, is the reference level is gonna be 0, right? 0 meter. Okay, and this one is we write down h, okay, h is the height and 1 by 2 rho, and the initial speed of the water here, it has no flow at all, right? So it's gonna be 0 square, right? 0 square and what else? Okay, let me check the flight here. Let me check the flight here. Okay, all right. Yes. Equals, right? Equal P2, right? P2 is PATM, right? The pressure at that location, the pressure caused by the air. The pressure at this hole, okay, caused by the air will be the same, the atmospheric pressure, and rho plus rho g. Y2, the height here is 0 and plus 1 by 2 rho v2. V2 is the speed, right? It's the speed of the water going out here, out of this hole. So it's gonna be Vx, which is what we would like to know, right? And you know that if you move PATM to be negative at this side, it's gonna cancel. It's gonna cancel another PATM, right? Both will disappear. And rho GH is right there. This one is 0, right? And you can have rho GH equals 1 by 2 rho Vx square, right? And of course, we use the same kind of liquid in this. We can cancel rho here. And of course, Vx will appear right now, will emerge right now as the square root of 2g and h, right? So let's substitute the numeric value to this one, right? 2 and 9.8, okay, and h is 0.5, and of course you're gonna have square root of 9.8 only, because 2 and 0.5 are gonna bring you number 1 only, right? So let's use the calculator. ผมขออนุญาตใช้คอมพิวเตอร์นะครับ Okay. The calculator here says octave rate, square root of rate, square root of 9.8, right? That's Vx, right? Okay, it's gonna be 0, right? อ๋อทำไมไม่ขึ้น Okay. Yeah. V is the speed, right? It's square root 2gh. It's 3 point. เอามาเล็กๆแล้วกันครับเพื่อไม่ให้มันเล็กๆนี่แล้วนะ alright, 3, yes, the same thing. Okay, here we get the approximation, which is 3.1305, and the unit of the speed is meter per second in standard way of the SI system, right? Yeah, we get that. And yeah, but our target here is that we want to find the distance, okay, away from the hole, right? If you project the hole onto the ground, and we need to find how far the water projectile motion gonna drop onto the floor or the ground on Earth, right here. Of course, we would follow the same manner in last time, right? We need to find, because of course any projectile motion has both the motions in y-axis, in the x-axis and in the y-axis, right? And you know that Vx is gonna be horizontal velocity here, right? It's horizontal velocity. Vx is actually u, okay, u for the motion along the x-axis, right? In but for the y, or the vertical motion, uy, what is that? Uy is 0, right? Because there is no initial speed of the water in this direction, right? The whole caused by the bullet is assumed to be in parallel to the ground. Okay, so uv is 0. So how high? They say that from the information Okay, the first quantity has been complete, right? The first thing, the speed of the water leaving the hole, okay, is 3.13. That's the speed. In the first question, right? We have delivered the answer already. We have found already the answer, right? Let's talk about the second question. If the hole is 3 meters above the ground, okay, so the hole here is 3 meters from the ground, right? So yeah, we know that we have to separate the motion into two axes, right? Let's consider the vertical motion first, right? The motion along the y-axis. Okay, let's consider the vertical motion. Of course, we have here uy, right? That's the initial speed. It's 0 meter per second, right? But the water drop is subjected to the acceleration, okay, on Earth, which is g, and it's 9.8 meter per second, right? It's 9 meter per second square, okay, and yeah, the height here, h is 3 meter, okay, 3 meter. Okay, the height here is different from the height in this expression. Okay, the height here is, okay, let's say it's h hole. Okay, it's h hole. The height of the hole. Oh no. We would rather not use. Okay, we will say h here is the height of the hole above the ground. Okay, h hole. And yeah, from the ground, right? And of course there will be final speed vy, but we don't know. We don't want to find it. But the important thing is the time. Okay, the time consumed from here, from the hole to the ground, right? We need to find the time along the y-axis, right? And ty, what is that, right? And of course, you need to recall some basic formulas about the motion subject to acceleration, right? You need to recall or remind yourself. มีใครจะเข้าที่ซูมไหมครับแล้วผมไม่เห็นเดี๋ยวคุณจะว่าผมนะครับ Okay, we have to remind ourselves about the possible formula that are gonna be chosen to solve this problem, right? What is that? We have v equal u plus at, right? We have what is, I know. V uat, okay, and v square equal to u square plus 2as, right? And we have another one which is what is that? S equal to ut plus 1 by 2 and at square, right? These are three. Actually, there are one more. There is one more, right? But these are three basics formula you can choose to solve this, right? And yeah, what is the variant? What is the correct formula for that? Of course, we know u, right? U, okay, the whole three equations involve u, okay. We have h, which is distance is going to be the second and the third, right? We want to find ty, right? So we have to deal with this. We have to choose this one, right? S equal ut is equal to ut plus 1 by 2 at square, right? What is x? S is h whole, right? H whole equal ut uy. Uy is 0, right? Uy is 0 and ty is unknown, right? And plus 1 by 2. A is the acceleration, okay? The gravitational acceleration g, right? And t is t squared of the axis y, right? The y-axis. And of course, in order to find ty, this term vanishes, right? This term disappear, right? It's gonna be 0, right? So we move number 2 to this one. We move g to the left hand side and take a square root on both sides. So ty, right, is gonna be square root of 2h whole divided by g, right? And of course, it's gonna be square root 2h whole. The height of the hole is 0.3 meter. Okay, we have nothing to change, right? It's the SI quantity. G is 9.8, right? 9.8. So you can put it into the calculator. In the calculator, we'll type right here SQRT 2 times 0.3 divided by 9.8. It's 0.24. Okay. อ้าว t ทำไมเราไม่เหมือนกันอ่ะ t ไม่ตรง The motion and the acceleration uy, yeah, 2, 3 divided by 9. Wait. It's not 0.3. No, it's not 0.3. It's actually number 3. I'm stupid. Sorry for that. This is number 3. Okay. ผมผิดเองเบอร์ครับโอเคดีนะที่มีจอนี้ไว้เช็คคำตอบตลอดเวลาเดี๋ยวถลำลึกไปไกลนะครับ 0.7825 second, right? Okay. ดีครับที่เปิดไว้เช็คด้วยตลอดเวลา Okay, and this we have this and I just right, the next step is that we have already finished the vertical motion, right? Now we will get back to the horizontal motion. Let's consider the x, the horizontal motion, motion. Okay, let's consider the horizontal motion, and of course, when you take a look at this, of course, the water drop or the water flow streamline is gonna move like this, right? Of course, the initial speed ux is what we have got before. Okay, it's 3 point something there, right? It's square root g. It's 3.1305 meter per second. That's the initial speed along the x-axis, and it's gonna reach, it moves right, and once it fall down and reaches the ground here, so it stops like this, right? And we get stand here, which is called the x, right? And that's what we would like to know. And yes, is there any acceleration acting on this water drop along the x-axis, okay, you would find that no acceleration, okay, along the y-axis. There's no a, no g at all. So we don't have to use these formulas for calculation, right? Because we don't have a at all. A is 0, right? It's yeah. The once you substitute a to be 0, right? Substitute a by 0, it's gonna have, you're gonna have s equal ut, right? So yes, we have s equal ut. ผมจะตามนะครับ Okay, sorry for that. Yes, you have s equal to ut, and yes, what is s is dx, right? The distance along the x-axis, and u is the speed, right? The initial speed. There is no final speed, right? Because there is no acceleration in this motion along the y-axis, along the x-axis. V is the speed, which is 3.1305, right? T is the time along the x-axis. Okay, Tx is equal to Ty, because the same water drop, right, reaches the ground along the y-axis, and it's gonna stop also the same time once it reach the ground here. Okay, T is there 0.7. Oh,นั่นไงครับ Okay, yes, it's 0.7. It's better if I write it in on another line. It's 0.7. Okay, we have just got it before right here. 7, 8, 25. Okay, and let's make the computation to that. It's right here, right? But actually, if you u is actually if you go further, it's, we don't have to make any approximation at all, because the first term is actually the time, right? It's square root g, right? It's square root g, and the second term is square root 2h whole divided by g, right? Divided by g, and you could see that you could cancel g, right? So it doesn't matter whether you use g as number 10 or 9.8 or 9.81. The x would be the same for you, for any student. It's gonna be square root 2 whole h whole only, right? H whole, which is square root 2 and number 3. Okay, square root of 6. So let's compute it. We cannot avoid, or anybody who could remember the square root of 6 would be also welcome. You don't have to bring, you don't need to bring the electronic calculator inside the midterm exam room. It's equal to 0.4495 meter. Okay, and that's it. Okay, that's correct. Okay, so we finish this example about the sheriff and a bad guy. It's cattle rustler, right? Cattle rustler. Okay, now let's move to another problem. Another problem is right here. Okay, it's not so fantasy as the previous problem, but anyway, it's acceptable, right? ผ ผมต้องจบที่เท่าไหร่10:10 right it's 9:50 right it's, 4:37 minutes okay they have also provided the figure too right okay a large pipe with a cross-sectional area okay this is the pipe and let's say this is the second stage the input side here is the output side okay the water flows out right get out of this pipe but unfortunately this pipe is special this one has bigger cross-sectional area okay the A2 here is greater than A1 okay this is the input side water get into this pipe a large pipe with a cross-sectional area of 1 meter square that saying 0.5 meter okay they say h is 0.5 meter all right 0.5 meter and narrows to okay the shape of this pipe is gonna reduce to 0.5 the A here A1 is 1 square meter and A here is A2 equal 0.5 square meter right yeah you would see this and the pressure at point 2 is at atmospheric pressure okay we have ATM PATM right here and where it terminates to a valve at point 1 okay this is the valve let's say it's a pipe with a smaller cross-sectional area point 2 is subject to atmospheric pressure PATM we have PATM the good thing of this problem is that they have already provided a figure and for you when you do the homework please also draw the figure related to that problem don't write down only the text okay ทำกันบ้านมานะครับโปรดอย่าเขียนมาแต่ตัวหนังสือนะครับให้เขาเรียกว่าอะไรวาดรูปมาด้วยนะครับที่ผมบอกให้วาดรูปนะครับโปรดวาดรูปมาด้วย alright YouTube มีอยู่คนเดียวนะครับตอนนี้2 คนอันนี้หายกับ OBS okay yes the valve is open wide right and water allowed to flow freely find the speed of the water leaving the pipe okay yeah we need to find V1 at this location P0 is also here okay we when they don't provide any pressure of the air that decrease okay we would assume that the pressure at both sides are the same okay and they have already provided there here P0 is at this side P0 is also allocated to this side so it means the pressure are the same the pressures are the same for both ends okay so now let's open a new empty page okay let's summarize this at the first location at the first location we have P1 oh sorry P is P number 2 first or second location actually second okay P2 is P0 or PATM right the atmospheric pressure and yeah, the height here, of course, it's higher than the first location. So h, oh no, we would say it's y, but y2 is h, okay, which is 0.5 meter, right? And v2 is the speed here, and I don't know, they don't also provide the information. They don't talk about they didn't provide the speed of the water at the input side or so. Any idea from you? มีใครทราบไหมครับ We would leave it as unknown quantity. Okay, we don't know it. Anyway, at the first location, P1, right? P1 is, of course, the same thing, P0 and equal to P ATM, right? And Y1 here is the reference side, right? So reference location is going to be 0 meter, right? And V1 is the output speed, which is also unknown. Sorry for that. Okay, we don't know two variables, right? There are two unknown variables, V2 and V1, right? Yes, let's substitute all these 3 or 6 values into the Bernoulli's equation. You say P1, right? Plus rho Gy1 plus 1/2 rho V1 squared equals P2 plus rho Gy2 plus 1/2 rho y V2 squared. Okay, yes, P1 is P0, so it's gonna be the same, right? So we can cancel P1 and P2, right? Because both are the same here, the same value, so it's gonna be both are gonna appear from the Bernoulli's equation. And what else? Of course, you know that here y1, right? y1 is 0, right? Because y1 is 0, we don't have to pay attention to this at all. 0, 2, right? And what else? We don't know v1, we don't know v2 too, right? And y2 is h. Okay, so we could divide the whole equation by row right now. Okay, we can cancel the row term from this one. We get 1/2 v1 square plus g y2, which is h actually, which is h, and plus 1/2 v2 square. All right, yeah, we left at this expression. We don't know both. They want to know the output speed here, v1, right? But we don't know either v1 or v2 because both v1 and v2 are unknown. So that's the result given by Bernoulli's equation. Okay, if you multiply the whole equation by 2, you're gonna have v1 square plus equals 2gh plus v2 square, right? And we keep it as the first equation from Bernoulli. Okay, that's the result given by Bernoulli. Okay, and what else could we do? Nothing more, right? So we arrive at a difficult situation because we don't we have two unknown quantities, v1 and v2. But if you get back to the continuity equation, what is that? Continuity equation says continuity equation. It says that the flow rate, right, the volume change per time equals A1 Y1, right, equal A2 Y2, right? So what do you think? A1 Y1, A2 Y2. Oh, no, I'm stupid. A1 V1, right? A1 V1 is not Y1. A1 V1, A2 V2, right? And yeah. Oh, 2 already appears. Okay, yes. We want to know V2, okay, from this expression, so we have to get rid of V1, okay, from this expression. And yes, we get rid of, remove, we have to substitute V1 into the expression only, okay, in terms of V2. Then we solve this equation. For V2, we will get the result, okay. Okay, from this equation, the continuity equation, you can get the relationship in terms of V1, right? V1 could be written as A2 divided by A1 and V2 right here, right? So that's the second equation. Now let's substitute equation number 2 into equation number 1, right? You're gonna have you're gonna get where is that? It's A2 by A1 square V2 square on the left, and on the right it's gonna be 2gh plus V2 square. And of course, we have to solve this equation for V2. We move V2 to the left hand side, right? Once you move the V2 to the left hand side, you're gonna have you're gonna get A2 by A1 square and minus 1, right? And here is V2 square, and you have 2gh on the right hand side. All right, now we have to oh, I'm sorry for that balloon. Okay, number 1 too. Here. Okay, we need to move the coefficient here to the right hand side. Okay, so V2 will be 2gh divided by, I don't know, it's A2 divided by A1 and square minus 1, right? And because this is the V2 square, if you want to find V2 only without the power of 2, you have to take the square root on both sides and you get the square root right here. Okay, and let's substitute that you have here 2 9.8 and h the height. The height, what they say is 0.5, right? What they say is h here 0.5 meter, and yes, we leave the number 0.5 right here. And the cross-sectional area,ใช่ไหมใช่นะ okay. Cross-sectional area is A2 is 0.5. เฮ้ยมาก่อนเฮ้ยมันใช่เหรอมาก่อน Let me make it smaller. Okay. Is that alright? Yeah, it should be here. 1 minus, right? 1 minus. Yes. 2gh 1 minus a1 by a2 but we have a2, right? A2 is 0.5. What they have there is A1 0.5. Narrows to 0.5. Sorry for that. I'm stupid. A2 is the cross-sectional area on the bigger side. The bigger side, I should not say it's A2. It's A1. Here A1. Okay. Alright. นะครับใส่อินเด็กซ์พลาดก็งงตัวเองครับโอเคไหม0.5 and then you have A2 which is 1, right? 1 divided by 0.5, right? And you get a square here minus 1, right? And you put it into the calculator. Okay, let's say we have calculator right here is square root of 9.8 divided by 1 by it's actually 2, right? It's 2 square. Okay, 2 square. Square root of 9.8 and 9.8 is 2 square minus 1. Yeah, it's 1.807 1.8074 meter per second. Is that all right? Is that correct? If we compare to the actual answer in the slide. Oh no, it's incorrect. ทำไมไม่ถูก Oh, right. Huh? 9 point. 2 and 5. H is not 0.5. H, why? The height. Let's say 5 meter. I'm stupid. This is not 0.5. Blur that up. This is 5. And yes, you have to multiply the whole thing here by times 10, right? Times 10. Huh? Square root 10 and it's 1 by 4 4 minus 1 3 and 4, right? Why? 2gh, right? 2 times 9.8 and 5. Yeah, it's 9.8 times 10. And okay, let's do the complete computation. It's right here. We have 1 part by 0.5. Yeah, it's the same thing. What happened? ทำไมได้อย่างเงี้ยทำไมได้ไม่ตรงหรอ 2gh h is 5 is 9 เขาผิดหรือเปล่าในสไลด์นะครับในสไลด์อาจจะผิดthe square root of 98 by 1 minus 0.5 and then square. Yeah, that's correct. เดี๋ยวนะครับทำไมถึงเป็นเช่นนั้นเขาผิดหรือเปล่า Rho GH where is Rho GH Rho GH should stay it's not correct here where is that okay as the number 2 h remains as the sixth term v1 is 1 here yeah 2 is Rho GH right you move it oh I'm stupid this is v2 okay but we don't want to find v2 okay yeah I'm stupid okay v2 is already correct which is 5 stupid okay 5.7155 but what they want to know is v1 so we get back to this equation okay to the second equation substitute again substitute v2 into equation number 2 okay v2 into equation number 2 yes we're gonna have that and v1 will be a2 by a1 right a2 by a1 a2 is 1 by 0.5 okay and times this value 5.7155 okay 2 times of that we're gonna get okay 2 times this one is 11 right it's the same thing right now we get it's 11 right 11.431 okay and meter per second okay and that's it for this problem sorry I get confused this is not the output side v2 okay v2 is the input side we want to find v1 okay now we arrive at the last problem to this chapter okay let me clear something about my throat okay we arrive at the problem about the house right เดี๋ยวผมขออนุญาตแคปเจอร์หน้าจอก่อนแล้วกันเพื่อว่าเดี๋ยวมันลืมนะครับ alright is that today เขาส่งลิงก์มาการประชุมนะครับตายแล้ว installation yes เดี๋ยวผมขอเดี๋ยว capture ของใช้สิทธิ์นิดนึงครับโอเคthis is for ใช้สิทธิ์ right okay the line for you hereที่สุดด้วยนะที่สุดนี้M604 strategy yes it's only single person ใช้สิทธิ์นะครับเองแล้วthis one in sorry installation okay and we're gonna need the alright we're gonna need this the screen capture for M604 right I hope everyone has done that info okay yes now moment let me get out of the Zoom right Zoom here and we get out of there and then you have to forward no let's get to that again I'm still oh my god still with oh my god in cloud again in meeting
recording in progress
oh my god it's this one copy กดผิดนะครับโอ้โหไปหยุดซูมเลย alright yes and you need to make the stream to YouTube again right oh my god this one and yes this one here throw an A and yes this one too right ขออภัยคนที่อยู่ช่องซูม YouTube นะครับผมไปกดผิดนะครับมันเลยปิดไปเลยนะครับalright นะครับเขามีประชุมนะผมขอออนของno
ซูม YouTube นะครับผมไปกดผิดครับมันเลยปิดไปเลยนะครับalright
meeting flash
นะครับเขามีประชุมนะผมขอออนของno
where is that it's
meeting flash
this one right เดี๋ยว604จะขอเลิกชาร์จนิดนึงนะครับเพราะว่าผมเสียเวลาเซตตรงนี้นะครับ alright okay
this one right เดี๋ยว604จะขอเลิกชาร์จนิดนึงนะเพราะว่าเสียเวลา
what's
เซตตรงนี้นะครับ alright
and where is that okay yes I hope so yes let's get back to the M604 เดี๋ยวปิดอินเทอร์เน็ตก่อนนะครับเดี๋ยวมันแรงแล้วแบบใช้ของเรานะครับfetish and we share the screen again trying starting and yes อันนี้ไม่ให้เข้าเลย anyway right all right yes let's get back to the this problem right นะครับก็yes okay and could I record it okay yes the problem here about the house okay it's not fully เราจะเลิกช้าประมาณ5 นาทีนะเพราะผมเสียเวลาเสร็จตรงนี้แล้วก็ดันไปกดปิดผิดซูมนะครับซูมเลยหายเลยนะครับคนที่ YouTube จะไม่เป็นไรนะครับแต่ว่าซูมนี่ผมขออภัยด้วยพวกชัยสิทธิ์อะไรจะเข้ามาอีกไหมนะครับเพราะว่าตอนนี้มีผมคนเดียวนะครับ alright ชัยสิทธิ์ขออภัยด้วยนะครับotherwise I'm gonna go get into the Zoom from the computer alright okay anyway let's go ahead with that this problem is something about the house okay the realistic situation water enters the house through a pipe okay anyway let's take a look at the house เขามสวเขาจะรับปริญญาครับดังนั้นผมคณะส่งลิงก์ให้ผมเข้าประชุมนะก็จะเข้าให้เขาหน่อยแล้วกันครับเพื่อแคปเจอร์นะว่าผมเข้าประชุมที่กลางเดือนนี้ครับมสวรับปริญญา okay the water is going to flow in this way right this is the water pipe if you look at the blue light here okay water supply right out of the house is going to be there is a pipe system by the tile and so on right the pipe will allow the water get into the house and the house is going to use this water for any purpose okay for several scenarios for several activities okay this is the inlet pipe and this is the typical pipe okay to the upper floor to upper stationary and but let's say this is the problem in a cold country like in the United States of America, and they need to have also the hot water supply. Okay, every house has its own hot water supply system. It's like you want, if you want to take a shower, you need hot water, right? Because the weather outside the house is very cold, extremely cold. It's like 10 degrees Celsius or something like that. It's not as warm as in our country. So yes, we need to make the water warm, right? Even for us in in Thailand in winter, you cannot easily take a shower, right? Without any water warming system, right? You need to have the I don't know, the warming device. Yes, and that's the thing in the United States of America. They use another pipeline system. It's denoted by the pink or the magenta one here. Okay, this is the hot water pipe system. Okay, and to the second floor, it's 1 centimeter pipe. Okay, the inlet or the input side to the house, okay, uses the bigger pipe. Okay, it's 2 centimeter of diameter pipe. Okay, this is the diameter. Yes, if you want to find the radius, you just divide by 2.ขออนุญาตช้า5 นาทีนะครับเลท5 นาทีนะเพราะว่าผมเสียเวลาเซตนะอยู่ดีๆคณะเขาเรียกว่าอะไรเขาส่งอันนั้นมานะครับเขาส่งลิงก์การประชุมเกี่ยวกับผมทำหน้าที่เป็นคณะกรรมการครับอยู่ในหอประชุมนะครับก็ต้องไปนั่งกับพวกนิสิตอะไรอย่างเงี้ยครับก็เลยต้องมีบทบาทตรงนี้นะครับ alright yes for us the cold water system and the hot water system are going to be supplied to the home house. Like if you want to wash your dish, your glass and so on, if you want to take a shower, you want to use the toilet, everything, right? Yeah, only the place where you take shower, you need the hot water, and also the place you wash your dish, your glasses and so on, right? You need hot water, otherwise your hand is gonna be frozen. Okay, it's going to be frozen. All right, that's the whole thing about the story here. Okay, whether you are in the the first floor or the second floor here. Okay, water enters the house through a pipe with an inside diameter 2 square meter. Is a big pipe here, 2 centimeter diameter, right? 2 เซนใหญ่ไหมก็ไม่ใหญ่มากเนาะโอเคat a gate pressure 4 times 10 to the 5. Okay, this is the what is PATM? Is not PATM, right? That's a great gate pressure. And the cold water pipe, okay, leading to the second floor to the bathroom, 5 meter. Okay. Oh, it's quite high, this house. Okay, 5 meter in the upper floor, and it's 1 centimeter diameter. All right, 1 centimeter diameter, and as in this figure 70, find the flow speed and the gate pressure in the bathroom. Find the flow speed and the gate pressure in this bathroom. And when the flow speed at the inlet pipe, this is the inlet pipe, is 2 meter per second. We are right. I don't know. Maybe this one, right, in the bathroom. Oh no, this one is 2 meters per second here. You have the inlet side speed 2 meter per second and ขออนุญาตเลย5 นาทีนะครับเพราะว่ามันก็จะไม่จบอยู่ดีครับโอเคไหมใช้เวลาลงมือทำไม่รู้จบหรือเปล่าครับโอเค5 meters above okay and yes it's time to solve right now okay I try to explain you in detail about this problem right and now it's time to solve and of course we're gonna have 3 I don't know we're gonna have 3 terms of the pressure right and yes of course the pressure could be divided could be separated into 3 terms pressure and pressure caused by the potential energy pressure caused by the kinetic energy right let's in order to not get confused let me check all the time the correct way to solve this right okay in order to find the flow speed in the bathroom okay this is the output side let's say this is the our second location this is the first location of course we're gonna use continuity equation right continuity equation it says that A1 V1 equal A2 V2 right it's like what is it Pascal equation or something like that it's yeah V2 is the speed of the water flow in the bathroom so that's our target we move A2 to the left hand side you get A1 by A2 times V1 right but you know that A is the area of the circle the cross-sectional area right and this one is gonna reduce it to pi r1 square right and pi r2 square you get V1 and here you have cancellation of pi and you get r1 by r2 squared times V1 right oh I'm stupid the next page should be here อันนี้จะลบยังไงokay yes V2 will be R1 where is that R1 is the inlet side right it is 1 times 10 raised to negative 2 right in meter and the radius of this one right which is 1 meter in diameter right 1 centimeter so it's gonna be 0.5 times 10 raised to negative 2 right and yes times the inlet speed here which is 2 meter per second right you're gonna get 4 meter per second okay for the water flow speed in the bathroom right and then we have to find the absolute of the gate pressure at the output here right so you know V1 you know V2 and they say P at the first location they say what is the gate pressure, right, in the bathroom. In the bathroom, we want to find the gate pressure. So, but P, what is the information? A gate pressure enters a house through a pipe, and a gate pressure of 4.0 10 to 5. So the pressure here is 4 times 10 to 5. Okay, 10 to 5. And yes, let's talk about P1, right? Plus rho G y1, right? Plus 1 by 2 rho V1 square equals P2 and plus rho G y2 plus 1 by 2 rho y2 square, right? And of course, you know, this is 4 times 10 to 5, right? And you move rho G H y1 to this location, you get a difference, right? Yes, and what we want is P2, right? So P2 will be, of course, P1, and you move y1 to that term, right? You do try to this location, so it's gonna be rho G y2 minus y1, right? And you move this term, right? 1 by 2 rho y2 squared to the left hand side. It's gonna be V2 is faster, so this term is gonna be negative, right? Negative of 1 by 2 rho and V2 square, right? And minus V1 square. All right, and let's substitute it. It's you know, this is actually the height. This is the height, okay, of the upper floor. The second floor, it's 5 meter. It's equal 5 meter. Okay, so let's substitute. It's 4 times 10 raised to 5, and minus the density of the water is 1009.8, right? And here is number 5, and 1 by 2, and 10 raised to 3, and V2 is the faster speed, right, which is 4 square minus 2 square, right? And you get the result. เดี๋ยวจบตรงนี้ก็จบแล้วครับเดี๋ยวเลยข้อหนึ่งไว้ต่อคราวหน้าครับ Okay, we put it into the calculator, right? Calculator 4E5 minus 1E3 times 9.8 times 5 and minus 0.5 times 1E3 times still ลืมเปลี่ยนภาษาแล้ว Okay, 4E5 minus 1E3 times 9.8 times 5 minus 0.5 times 1E3 times 16 minus 4, right? It's 3, 4, 5. ทำไมมันไม่ตรงอ่ะ Yeah, it's negative. The speed is incorrect right here. It's not 4. It's square here. I'm stupid. This is square. So this one should be 8. It's not 4, okay? So this one too, right? Should be 8 square. Should be 8 square. นะมีเบอร์นะครับอย่างนี้นะคุณอย่าเบอร์นะโอเคป่ะ it's 64 it's 320, right? So it's equal to 3.20500, and it's actually 3.205 times 10 to the 5, and it's Newton per square meter, right? Or it's called Pascal. Okay, and that's it for this problem. I'm sorry for being late. See you next time. Okay, see you next time, and see you next time. And the homework is something about Bernoulli's and continuity equation. M604 สวัสดีครับบ๊ายบายครับถ้ามีข้อสงสัยอะไรก็โปรดแจ้งครับ M604 โอเคบ๊ายบายเท่านี้ก่อนนะครับสวัสดีครับโอเคlet me check Zoom United okay oh the last person กิติพันธ์นะโอเคI'm meeting by Triton. Prediction and Mary. G.SWU and 32 Select submitting. Okay. Candidate. Yes, sir. And this one, right? And, yes, other. And Maryland first. And BALIT. SK.AC.th. Okay. So app. just first done zoom เอา Thailand ไป Okay. Yes, just close it like that. In yes, it's gonna be there. No. Yes, sir. And yes, we have to send. We have to send the link, right? Link to M605, right? The link to M605 super sync ระดับไหน Oh, this is let's see 605. Oh yeah, this one in 2 or this one to right, this one and this one right, keep the pan to right, 605. Okay. Okay, M605, are you all right? M605. M605, are you all right? ทุกคนเรียบร้อยนะครับ605ครับOkay, ปานทัศน์ and ธนกร right ธนกรพิมพ์ชื่อมาแล้วนะครับ Okay, ธนกรปานทัศน์ครับ Okay, so when everything is ready I'm gonna มีอะไรเกิดขึ้นเขามีพิมพ์แชทมาตรงนี้นะครับเขียนว่าก็ธนกรมา1คน alright, just let's move to let's share the screen. We need to open the file of M605 จริงๆผมเตรียมบทที่6ไว้แล้วนะครับแต่ว่ายังไปไม่ถึงกันครับ Alright, yes, I hope that everyone is already there, right? Two students, 2 people in the Streamlabs channel, and no one more, right? Let's go ahead with this to not waste our time. Okay, good morning, everyone. Welcome you to SCI33206. This is the section for M605. Okay, this is for M605. And let's go ahead. That we have a remaining problem we didn't complete last time, right? That's the problem about sheriff, okay, or somehow like a policeman and so on, and a thief, okay, which is called cattle rustler. Okay, the policeman tried to shoot this bad person, and but unfortunately the bullet has missed him, and it just hit the wall of the water tank of the town. Okay, this is the water tank of the town, and once the bullet get into one side of the tank, of course we are going to have the hole, right? And the hole here will allow the water going out. Okay, the water will flow and downward. Okay, and yeah, the question is determine the speed, okay, the horizontal speed of the, is that correct? Yes. The horizontal speed of the water that starts to flow at this location. And that's the first question. For the second question, what does the stream, where does the stream hit the ground, right? So how far the water will hit the ground, and that's our task. We have to solve this. Okay, yes, let's talk about first the speed that we get out of the hole here at the container, at the water tank. Of course, it's up to you. Let's say this is the first location, this is the second location, right? At the first location, right? At the first location, what about P1, which is the pressure at this location. Okay, this is the pressure caused by the air. It's around PATM, right? 3.102 times 10 raised to 5 Newton per square meter or Pascal or something like that, right? Yes, we are going to have that pressure, right? And they have finished, have completed the meeting already. Okay, the next one is Y1. Y1 is the height of the first location. Okay, what is that? It's Y1, right? It's the height here. Y1 is Y1, okay? We don't know. But this one, we know that this is 3 meters. That's the information from the problem, right? So Y1 is gonna be the addition of 0.5 and 3 meters, right? So you're gonna have 3.5 meter here, and next the speed at the first location. Okay, of course the water is start to fall down, right? And when the water here is bleeding, right? It's going out. This one should have also the speed, right? But assume that the tank is very, very large. Okay, when the tank is very large, we assume that when they don't talk about the information, the size of the tank, okay, we would assume that the tank is very large and the water reduction speed or the water levels flow here is gonna reduce, okay, reduce with the zero speed. So V1 is approximately, okay, V1 is approximately 0 meter per second. All right, we assume that for simplicity. Otherwise, we couldn't solve this. They don't provide enough information.กิตภพพิมพ์ชื่อมานะครับที่ช่องนั้นครับแล้วก็อันนี้ก็มีพวก ordinary guy คือใครละพิษไม่ใช่ไหมพิเชษพงศ์ของ605ใช่ไหมครับไม่ใช่เนาะปัทานินนี่604ใช่ป่ะกฎชวงวัดใช่กฎชวงวัด605นะครับมีพวิทย์มีพฤตินันนะครับพวกนี้นะโอเคใครจะเข้าปฏิหารนะ I'm sorry for that I didn't see you ธนกรปฏิหารนะครับ alright yes ธนกรปฏิหารนะครับ yes who else yes มีคนไหนจะเข้าอีกครับ alright yes now we have this right yes now we consider the second location, which is the bleeding side, the hole here, which is caused by the bullet. Okay, the second location at the second location. Okay. Talk about we will talk about the pressure, the height, and also the speed, right? It's P2, right? P2. Okay, actually the pressure here should be a little bit different from the pressure at location number 1 because 0.5 meter, but 0.5 meter is not a big deal, right? The height is not so significant. The height is not so significant, so yes, the height is not so significant. We assume that this one has also the same pressure. Let's say it's approximately, again, the same PATM. Okay, PATM. And Y2, what is that? The height of the second location is 3 meters. 3 meters. V2 is the bleeding velocity. Bleeding speed here is what we don't know, right? It's unknown quantity. So once you have all these 6 values, we're gonna start the Bernoulli equation. Bernoulli สะกดไงOU, right? Bernoulli equation. Okay. And yes, you just go ahead with the first term, right? P1 and plus rho G Y1 plus 1 by 2 rho V1 square equals P2, right? The second location plus rho G Y2 plus 1 by 2 rho V2 square. Okay, the formula is quite long, but it doesn't matter. Okay, P1 is PATM, right? PATM plus rho GY1. Just leave it, okay? We know that rho GY1 is greater than that, right? So we move rho GY2 to the left side. We get rho GY1 minus Y2. And what we want to find is V2, right? So yes, of course, we have right here 1 by 2 1 by 2 rho plus 1 by 2 rho v1 square and equals, right? Please note that P2 is the same, right? It's PATM and plus, right, the remaining term, which is the 1 by 2 rho v2 square, right? So you have the cancellation of PATM right here, right? And please note that once you have removed first PATM terms, you would have the common factor, which is the density rho, right? Of course, it's water, it's not difficult, it's 1000, but it's easier for us to remove this term so that our life is gonna be easy, okay? Cancel rho in all these three terms. So you get GY1, V2, Y2, and V1 square, and V2 square right there, okay? You get right now G and Y1 and Y2 is the difference, right? Which is the height here. So it's delta Y or the H, right? The height of the hole, the depth of the hole under the water level, okay? And we get the next thing is 1 by 2, okay? Please note that V1 is the speed of the water flow and it's approximately 0, right? So this term just vanished, okay? We don't need to pay attention anymore to that term. Yes, the right hand side you have 1 by 2 V2 square, right? And yes, you can solve it for V2. V2 is gonna be the square root of 2GH. All right, you get V2 as the square root 2GH, and you know that H is the height, which is only 0.5, okay? So V2 will be square root of 2 G9.8, right? And 0.5, okay? Simply speaking, it's square root G, okay? Square root G. It's square root G, but in numeric way, if you want to compute it, square root of G is 3 blah blah blah. If I can't remember exactly, 3.1305, okay? It's approximation. .1305 and meter per second. All right, and that's the first quantity, right? The second quantity is the distance here, okay? How far does the water drop when the water reaches the ground? How far is it? Okay, how far is it? In order to deliver the answer to this problem, okay, ก่อนนะพวกก่อนพิรทัศน์นี่ห้องอะไรผมจำไม่ได้ห้อง5เนาะกฤตภพวชิรวิทย์พวกนี้นะห้อง5นะโอเค อยู่ด้วยกันมานานผมยังจำไม่ได้ alright yes Yes, yeah. We have to determine further the motion of the water streamline here. And of course, they add to the water has the projectile motion like this. Of course, we can decompose the motion into two axes, right? Along the horizontal way and along the vertical way. Okay. The motion has two components. Okay. The first one is horizontal way. The second one is the vertical way, right? But these two components happen at the same time, like vertical way. Okay, let's consider the vertical way first. Okay, let's consider the vertical motion. Let's consider the vertical motion. Now we have, you know that the vertical motion is the water drop. Okay, start like that and it's gonna move downward to the ground, right? It's gonna reach the ground here. But please note that the water drop doesn't have the initial speed at all. Okay, of course it has initial speed v2, which is what we have just got previously, 3.13 meter per second. But that's the horizontal speed. It's not the vertical speed for the vertical motion. Okay, there is only the component along the x-axis. There is no component along the y-axis. So the vertical way, in the vertical way, we don't have the initial speed for the water drop. So what does that mean? It means that uy, which is the initial speed along the y-axis or the vertical motion, is 0 meter per second. Okay, it's only 0 meter per second, and of course it would reach with the final speed vy, which is what we don't know. But I'm not sure whether we want this, we want to know this speed or not. Maybe we don't want to know that. Okay, but anyway, we know that the height here, the height of the hole is 3 meter, okay, above the ground. And what else? We want to find the time consumed for the water drop to reach the ground, and it's ผมไม่ได้เช็คว่าเสียงพอหรือเปล่าด้วยเนาะขอเช็คนิดนึงแล้วกันครับเสียงไปไหมนะครับเพราะว่าย้ายซูมมาเครื่องนี้นะครับตอนนั้นที่คณะประชุมกันเรื่องรับปริญญาครับOkay, let me check a little bit whether it works or not. All right. Okay. เดี๋ยวขอเช็คเสียงก่อนนะครับเดี๋ยวคนอยู่ในซูมไม่ได้ยินนะครับเดี๋ยวจะบ่นผม Where is that? This one, right? The control. Yes, sound to sound output to where's that? It's real tech audio. Okay, test 1 2 3 คนอยู่ที่ซูมได้ยินเสียงผมไหมครับคนอยู่ที่ซูมครับ Otherwise I'm gonna get into the meeting here from this machine to check the sound. All right. Video by tracing. Host.cbot. Yes, sir. Yes. Test. 1, 2, 3. Okay, the sound is great. Okay, the people in Zoom would be able to hear everything, right? Yeah. Question. All right. Oh, I'm not sure whether I shared the monitor to you. I didn't share the monitor. I'm stupid. Okay, sorry for that. All right. Yeah. Right here. โอเคโอ้อยู่มาตั้งนานนะคนในอยู่ในซูมก็ไม่บอกผมเลยนะว่าคุณไม่ได้ยินอะไรกันนะครับ anyway chat and let's look at the chat in this one, right? If possible, I'm gonna take the screen capture, right? ก็เช็คดูว่านับใครพิมพ์อะไรหรือไม่นะครับที่อันนี้ที่มีก็มีรวิพลนะครับพวกกดชงวงวัดลงมาเนาะเป็น605นะครับ alright yes okay and the what is that is the line application and the people in here the one in speed ยังโอเคนะ these two this one and this one and this one too, right? Okay. Okay, let's go ahead with our story. We want to know Ty, the time consumed along the vertical motion, right? We know the initial speed. We don't know the final speed. We know the distance along the y-axis in the vertical motion, right? So, of course, there are a few formula that you need to remind yourself for the Newtonian motion, right? The motion related to acceleration, the motion that has acceleration in that, right? So the motion with acceleration, what is that? We have v equal u plus at, right? We have v squared equal u squared plus 2as, right? And you have s equal ut plus 1 by 2 at squared, right? And what you know is s, right? S, which is h hole, right? The height of the hole caused by the bullet. And the next one is the initial speed, right? U is uy, which is 0 meter per second. And the next one is, of course, we know the acceleration, right? The acceleration caused by the Earth, which is g here, the vector g, okay? The gravitational acceleration on our planet, on the Earth. Okay, we know A, right, which is G actually 9.8 meter per second square. And we want to find Ty, okay, T, which is Ty, and what is that, right? So the one that we have to choose is this one, okay, this formula. And just let's substitute everything into that expression. S is gonna be, oh, I'm sorry for that. S is H hole, right? The height of the hole, H hole. And ut, the initial speed is 0 times t, of course. Ty is what we don't know. The Ty, oh, I'm sorry for that. Ty plus 1 by 2. A is the acceleration, which is d, right? It's actually d. And t squared is Ty squared, right? So if you want to solve this, you would get Ty equal, okay, 2h whole divided by g, right, and square root of that, okay. And yes, square root of what? Square root times 2h whole. What is the height? The height of the hole is 3 meter, right? It's 3 meter, and here is 9.8. Again, if you put it into the calculator, you're gonna get 0.7825. 0.7825 second, right? It's second. All right, let me check whether it's correct or not. Yes, it's already there. And yeah, that's the result after we consider the vertical motion, but that's not our target yet. We want to know the distance along the x-axis here, how far the water projectile motion is gonna reach the ground here, how far is that. So we want to find dx from the horizontal motion. So let's consider the horizontal motion. All right, let's consider the horizontal motion. So what is the initial speed? Of course, the water drop is gonna start like that, and it stop. Here is only the x component, right? It's gonna reach like this. It start with ux as v2, right? Which is the here 3.1305. 3.1305 meter per second. And the final speed, what is the final speed? It should be the same, because there is no acceleration acting on this water drop at all. Along the y-axis, there is no force acting on to the water drop. So there is no force acting on the water drop. So Ax is 0. So we don't have to deal with the Newtonian formulas, okay? We just substitute A as 0 here, this one, right? If you substitute A at 0, you get S equal to ut, right? You get S equal to ut, and that's the basic formula of the speed, right? And yes, you want to know dx, right? The distance along the x-axis for this motion, right? So dx will be u, the speed, which is 3.1305, and t is the time 0.7825. Yeah, you get dx approximately right there, right? And if you don't want to go ahead with that, it's dx. Oh, sorry. Dx is the product between velocity, right? Velocity is square root g. You can see here it is the square root of g, the gravitational acceleration on Earth. It's the square root of g, and t is the time, right? The time consumed by these motions. It's square root 2h divided by g. Square root of 2h whole, the height of the whole, divided by g, right? You could see that g can cancel even inside the square root. G can cancel each other. We're gonna get finally square root of 2h whole, right? 2h whole. And it's actually square root of 2 and 3 meter, right? The height of the whole. Square root 6, what is that? Square root 6 is anybody who can remember. Is there anybody who can remember the value of the square root 6? Square root 6 is 2.4495 meter. Okay, and that's it for our problem. Okay, the distance here is approximately 2.45 meter, okay, away from the hole or the wall of the container, the water tank. All right, and that's the way we could find that's the way we could find the distance, okay, along the x-axis. Now let's move to the next problem. Okay, the next problem is somehow like this, right? We have three problems to the Bernoulli's equation. Okay, here we have a pipe like that. Okay, that is a pipe, and yeah, the information of this equation is somehow like that. Let's take a look at this. Okay, you have an input side here. This is the output side. The water flow into this pipe, okay, and the water will get out of this pipe. And you know, this is the bigger cross-sectional area. This is the smaller cross-sectional area. And of course, the water should have its own velocity, which is denoted by V2. The water out of this side should have its own velocity, which is denoted by vector V1. This is the first location. This is the second location. If you want to comply with the Bernoulli's equation, Bernoulli's equation is valid for the summation of pressure at different locations, right? But here we have two locations, number 1 and number 2. Okay, now let's get into the information of this example. A large pipe with a cross-sectional area of 1 square meter. So this A here, this is the large pipe. A2 is 1 square meter, and descends. It's gradually decreasing. It goes in the decreasing like this, right, in descent way. 5 meters. So this is 5 meter. The height here is 5 meter. Okay, it doesn't matter how curved, how shape is it is, okay, and it goes down to narrow to 0.5 square meter. So A to A1, which is on this side, is 0.5. square meter. Okay, 0.5 square meter, and it terminates in a valve in point 1. Okay, yeah, of course, it is a kind of pipe. Okay, the valve has the lower cross-sectional area. Okay, in order to control the water flow, right? นัทวินนะมาเพิ่มมาใหม่นะครับ Okay, yes, let's go ahead. มีใครจะเข้าที่ Zoom ไหมครับไม่มีแล้วนะ yes, let's go ahead with that. The pressure at point 2 is atmospheric pressure. So pressure here is P0, 3.120, 3.01, blah, blah, blah. I cannot remember atmospheric pressure. It's P0. And the valve is open wide, and water is allowed to flow freely, so the water can flow easily without any restriction. And yeah, they say also P0 here. The pressure at this location is subject to also the atmospheric pressure P0. All right, and find the speed of the water leaving the pipe. So, what is V1 at this location? Okay, V1 with our vector is the magnitude. V1 with the vector with the arrow on top is the vector version. Okay, it has also direction. And if you take a look at this, you can see that this is the symbolic meaning of this figure. The vector here, the red one, the red arrow, has the length like this, and V1 has a longer length, okay, like that. So let's go ahead with that. At the first location, at the second location. At the second location, you have P1, right? Oh, sorry, P2, which is P0, and it is PATM, right? And Y2, the height of Y2 is 5 meter. I don't know, but the difference between these two, right? I don't know. And V2, velocity V2 is also unknown, right? What about at the first location? What about the first location? At the first location, we have P1, right? Equal P0 and equal PATM, right? The atmospheric pressure. And Y1 is the height at this side, right? So Y1 equal unknown. Okay, we don't know V1. We don't know the height of this one, right? And V1, the output speed, that's what we want to know, okay? They asked us to find V1 here. So let's open the next page in, let's take a look at the Bernoulli's equation. Bernoulli equation. Bernoulli's equation. Okay, Bernoulli's equation says that P1 plus rho G Y1 plus 1 by 2 rho V1 square equal P2 plus rho G Y2 and plus 1 by 2 rho V2 square, okay, and of course both P is equal to P ATM, right? And you then have if you move this term to the left hand side, you're gonna have rho g y1 minus y2, right? And yeah, we have the same term 1 by 2 rho v1 square equal the right hand side here is also PATM, right? PATM, the pressure at the atmospheric level, and plus 1 by 2 rho v2 square 2, right? The last term. Yeah, we could cancel PATM on both sides. And of course, this is the common term. There is a common term. Rho, we could cancel rho in this equation, right? Yeah. You know that y2 minus y1 is actually h, right? This one is h, and it is 5 meters. Okay, it's h actually. So you get g h and r plus 1 by 2 v1 square and equal 1 by 2 v2 square, right? If we multiply the whole equation by number 2, so we get 2gh plus v1 square equal v2 square. But our target is v1 square, so v1 square will be v2 square minus 2gh, and that's it. We could not do anything more, right? We keep it as the first equation. That's the result from Bernoulli equation. Okay, once we try to leave every term into that. Okay, let's go ahead with that. But we don't know also the velocity at the input side v2. Okay, there are two variables v1 and v2, but we have only a single equation. Is it possible to solve this system? No, it's impossible, right? We need to have one more equation so that we can solve two equations for two variables, right? So which equation should we call for? Which equation should we deal with in order to solve this problem? Yeah, we will recall the continuity equation. Continuity equation. Bernoulli equation has already been used, right? Continuity equation says that the volume per time, right, the flow rate of the fluid per time is equal to the cross-sectional area at the first side times the velocity of the fluid at the first side, and equal to the cross-sectional at the second side times the speed at the second side. We get that, right? But our target is v1. We're gonna find the expression of v2. So, okay, so that we can substitute v2 into the equation number 1. So v2 will be a1 by a2 times v1, right? We substitute v2 into this expression, right? Yes, on the left hand side. On the left hand side, you're gonna have okay. On the left hand side, we have v1 square equals v2 square, right? It's gonna be a1 by a2 n square, right? And v1 square 2, right? And minus 2gh, right? In order to solve this one, we move 2gh to the left hand side, we move v1 to the right hand side, so we get 2gh equal a1 by a2 square minus 1, right? And times v1 square something like that, right? Yes, we would move this coefficient to the left hand side so that we get v1 square. So v1 square will be 2gh divided by a1 by a2 square minus 1, right? Yeah, let's substitute that. Okay, so v1 will be square root of 2gh a1 by a2 square minus 1, right? Oh no, let's go ahead with that. v1 will be square root of what? Square root of 2 9.8, and the height here is number 5, and you have here a1 what is that? A1 is the cross-sectional area, right? A1 is 0.5. by A2, which is number 1, and we have that minus 1, right? It's gonna be imaginary number, right? 1 by 4. Yeah, we could not find it. My God. Because A1 by A2, A1 is less than, right? Is that correct? I think V2 will be, yeah, we don't want to know V2 is like this. V2 is A1 by A2 times V1, and V1 square will be A1 by A2 square. Yes, you move it to right to the left hand side and you get a positive. Y y2 minus y1. Yes, no, this one is incorrect. Y1 minus y2 is not h, okay, it's negative h, negative 5. So this one is negative 2gh, this one is negative 2gh, this one, once you move to b here, it's going to be positive, and on the right hand side you get positive here. You move to the left hand side, it's negative, and you have the negative here again, and of course negative, and it's better to not have negative into that, and we write it in a different way, in the opposite, in a reverse way. 1 minus A1 by A2 square, right? So 1 minus A1, which is 0.5, 0.5 square meter divided by 1, right, which is the cross-sectional area of the second location, a square, right? And you leave it into the calculator. Okay, you leave it into the calculator, you will get where is that? Okay, square root 2 times 9.8 times number 5, and 1 minus 0.5 square Yes, you get 11.431. 11.431 meter per second. Okay, that's the speed of the water getting out of the speed of the water getting out of this side by the output side. Okay, we get 11.431, and now let's move to the last question. Okay, last question right here. Okay, ขออนุญาตเข้าน้ำแป๊บนึงนะครับจบสำหรับข้อนี้เราเหลือข้อสุดท้ายนะครับแป๊บนึงครับเดี๋ยวมานะครับ Okay, let's continue our story, right? Yes, we arrive at the last example of the topic Bernoulli's equation, right? The topic of Bernoulli equation. It's quite close to reality, right? You know that in physics, you will deal with the problem that is really close to our real life situation. Okay, water enters a house through a pipe with an inside diameter of 2 square centimeter at a gate pressure. This is the absolute pressure, I think. Yes, 4 times 10 to the 5 Pascal. Okay, only this quantity is not in the SI scale here. It's 2 centimeter. The cold water pipe leading to the second floor bathroom 5 meter above is 1 centimeter diameter. Okay, as in figure 70. So let's try to understand this scenario. Okay, if you live in a town, and if this is the street, under the street, there is the authority would provide a water pipe, okay, from the town to your house. This is the inlet pipe. The water will get into this. The water will get into this pipe, okay, and you can use the water for any purpose, okay. Up to you, as you like. Okay, and yes, Once the water get into this, the water will be separated into two portions. The first one is going directly to your tap, your washing place, okay, to wash the dish, to wash the glass and so on. And this the water which is supplied to your toilet, to your bathroom, and another portion of the water is sent to this device, okay. This house located in a cold area like in the United States of America, because this is the original source of this figure, or in the European continent. Okay, you are living in a cold water. You need to make the water warmer by using the hot water tank. Okay, it's also the pump together with the boiling process here, okay, to make the water hotter. And then the hot water is applied to several places inside the house, okay. And that's the whole system. And the difference between the first floor and the second floor is 5 meters away. And the inlet side has 2 centimeters in diameter, okay. This is the inlet pipe. And the inside the house, they use a smaller pipe which has only 0.5 centimeter in diameter, okay. And the first question to this problem is the following. They want to know, find the flow speed, okay, in the bathroom, yeah, okay. And the gate pressure in the bathroom, they want to know the gate pressure at the pipe, at this location in the bathroom, okay. Now it's time to solve this problem. Let's draw open a new page here. All right, we want to know the water speed, which is V2, right, and the bath here. So find V2, right? What is V2? We need to use the continuity equation. We assume that there is no water leak at all inside this house, so the continuity equation is valid. Okay, the water cannot be compressed in terms of volume, right? So we're gonna use the A1, V1 equals A2, V2, right? And yeah, we would be able to find V2 from this ratio A1 by A2, and something like that, times V1, right? And yes, of course, A1, as you know, A is the cross-sectional area of the pipe, which is circle, right? So pi r square, right? You get pi r1 square at the numerator, and you get pi r2 square at the denominator, and V1 here. All right. And yes, V2 will be, of course, we get the cancellation pi, right? And we get R1 by R2 square here times V1, right? R1 is the radius at the inlet side, at the location number 1. It's 1 centimeter, 1 times 10 raised to number 2. Right, and at the output, in the output side, location number 2, you get 0.5 times 10 raised to negative 2, right? And times V1, which is the speed at this location. They say here that the flow speed at the inlet pipe is 2 meters per second. So you have here number 2. All right. And of course, you get cancellation here, and 1 by 0.5 is number 2. Right. Sorry for that. You should have also number 2 as the power. Sorry. Yes. ขออภัยครับผมจามครับ Yes. You have number 2 right here. Okay. 2 square times number 2. It's equal to 8 meter per second, right? And that's the first quantity you could deliver to the first sub question right here. Okay, find the flow speed. The flow speed is known right now 8 meters per second at the bathroom. Okay, in the bathroom, and the gate pressure, the absolute pressure in the bathroom. So let's continue this derivation. Yes, of course. Let's take a look at the Bernoulli equation, the tool for us. Bernoulli equation. Bernoulli's equation. Yes, of course, we have Bernoulli's equation. We have P1 plus no, it's potential. It's rho g y1 plus 1 by 2 rho v1 square, right? And equal p2 plus rho g y2 and plus 1 by 2 rho v2 square, right? Yes. Of course, you know that the gate pressure at the inlet side, they say the gate pressure at the inlet side is 4 times 10. Okay, they say P1 equals 4 times 10 to 5 Pascal or Newton per square meter, right? You know this value. And they want to know P2. So we know P1 with this amount of pressure. We want to find P2. So we move every term to the left hand side, right? Of course, P2, right? So we would get P1 in the first term, and plus rho g y1 minus y2, right? And we get also the plus 1 by 2 rho v1 square minus v2 square. Okay, we move these two terms to the left hand side, and P2 is going to be P1, which is the gate pressure. Okay, let's say it's still P1, right? Plus rho g y1 minus y2. What is that? The height of y1 minus what we know that y2 is greater than y1, so this term is negative. Actually, this term is negative. Negative of what? Negative of the height here, which is 0.5, right? Which is 5.0, and plus 1 by 2 rho. What is that? V1 square is 8. Oh no. V1 square, I don't know. No, V1 is 2 meters per second. So this one is actually incorrect. It should be negative, right? It's negative, right? And because V2 is greater than that, so we're gonna leave the bigger term at the first location. So at the first position, V2 square minus V1 square, right? So now we have P2 like this. P2 will be P1. What is P1? It's 4 times 10 to 5, right? 4 times 10 to 5 minus rho is 1000, G is 9.8, H is the height, which is number 5, and minus 1 by 2, rho is 1000, sorry for that, and V2 square is 8 square minus V1, which is the inlet speed, is 2 square, right? You leave it into the calculator, okay, you leave this into the calculator, you get, I don't know, let's take a look at the calculator. It's 320,500. It's Newton per square meter, right? It's the pressure per square area, right? Per area. So in terms of Pascal, you would get 3.205 times 10 to 5, okay, and Pascal, okay, and that's it for the gate pressure here. All right, and yes, of course, they want to know how much time would be, let's move to the bigger figure here, okay, how much time, what time is it? We still have 6 minutes left, okay, let's go ahead with it. How much time would be required to fill 100 liter bath tube, right? Bathtub. Yes, if you want to lay it out inside your bathroom, right? You need the water of 100 liter, okay, into that like a jacuzzi or something like that. Okay. So they want to know how much time. If you open the water tap and you need to wait, right? You may go somewhere else to do something, okay? And you don't have to wait for that. And yeah, use the physics to calculate, determine how much time you're gonna wait for the water to be fully filled in that bathtub, okay? So this question asks you about time. Okay, what is that? Which means you have to deal with the water flow rate, right? Water flow rate in terms of volume, right? Because they ask you about 100 liter of water, so it's delta V by delta T, right? Okay, and as you know from the continuity equation, let's get back to continuity equation. Continuity equation again. You know that delta V by delta T equal A1 V1. Oh, sorry for that. There is no ratio here. A to V2, right? But here we are dealing with location number 2. You may also use A1, right? It's up to you. And A2, V2 too, right? So delta T is our destination. We want to get delta T. You just move delta T to the right hand side, and you move the product of A2 and V2 to the left hand side, okay? And delta T is gonna be delta V by A2 V2, right? Because we are considering the water in the bathroom, location number 2 here. Okay, let's move right that. Okay, yes, delta V, of course, it's 100 liter. But what is liter in SI scale? 100 liter is 1 times 1000, right? It's 1000 cubic cubic centimeter, right? If you want to convert it to the SI scale, it's gonna be, what is that? It's 100 times 10^3 and times 10 raised to negative 6, right? That's the unit of the volume in SI scale, right? So it means you have what is that? 0.1. Okay, only 0.1 cubic meter. That's the water in your jacuzzi or bathtub. All right. So what is A2 in this location? A2 is pi R2 square, right? And you know this is only 0.5 centimeter, so it's going to be 0.5 times 10 raised to negative square centimeter, right? No, radius, right? So negative 2 meter square, like that. And V2, of course, V2, the speed here, as we know before, it's 8 meter per second, right? 8 meter per second. And yes, if you substitute everything, right, into this equation, you could get delta T, right? Delta T will be, what is that? Delta V is 0.1 cubic meter, and A2 is like that. It's pi. Okay, pi and 0.5 times 10 raised to negative 2 and square, and V2 is 8. Okay, delta T equal 0.1, like that, right? You have to put everything into the calculator and you get time 0.1 times pi times 0.5 e minus 2. That's all right. Pi r square. That's the area, and times 8, right? You get 159.15. Okay, approximately. Yes, and the unit is in the standard, right? In SI unit, it's second, right? And if you want to know it in minutes, it's around what is that? Divided by 60 seconds. It's around 2.65 to 6 minutes. Okay, minutes. All right, and that's it for this example. We have completed this chapter. Okay, this chapter is finished at the story about Bernoulli's equation, and next time we are gonna start with this chapter, the new chapter. M604 didn't complete this example yet. Okay, they still have some time about the calculation of time waiting for the water filling into the bathtub. Okay, actually I have prepared the slide for the next chapter, atomic physics, but we are running now out of time. Okay, let me send you again the screen capture about your appearance in the class today, right? ขออนุญาตส่งอันนี้ให้อีกรอบนะครับว่าใครเป็นอย่างไรนะครับ this one and this one too, right? Andนะครับถ้าใคร มีหรือไม่มีอย่างไรก็โปรดพิมพ์แจ้งมาเสียนะครับ alright okay we have to quit the lecture right now okay see you on Wednesday if there is nothing change okay if nothing happens we need to continue our lecture on next Wednesday okay if you have any question just let me know if not then we're gonna quit this meeting this classroom right now okay บ๊ายบายครับสวัสดีครับ Yes, we will stop. Stop the meeting here in Federation. That's meeting Federation in. Let's talk about Zoom here. Ended for everyone. In the OBS too, right? Streamlabs. Yes, of course. And this one.